Why, hello! I was just reading my comic. Well, actually, no, I wasn't. I just never closed this window. Alright, and then here you go. This is exercise 8. Alright, the final exercise I need to go through with you guys. There's still the problem set, and yeah, the other problem set. But never mind. Alright, let's pretend this is the last thing. Alright, we'll all say theory goodbyes at the end of this, and we will all, hold hands and sing a song or whatever it is people do. Okay, anyway, the fun thing about this exercise, alright, is that I don't have the answers. Alright, so you get to watch me stumble through finding a solution. So this ought to be fun, alright? But yeah, at the end of the day, I will upload these solutions. Okay, so recursion, alright, recursion, main concepts, alright? Recursion, the main concept of recursion is recursion. Okay, sorry. The main concepts of recursion, you have to do 3 things, alright? The function has to call itself, alright? You have to change the state, alright, and reduce the problem, alright, and it has to work towards a goal, alright? And yeah, well, there's also a base case you have to watch out for, okay? Base case meaning the lowest possible case. Alright, the minimum, the final case. I'm not explaining this very well. Not explaining this well. Okay, anyway, so never mind all that. Let's move on to doing the exercise where I will, probably mess up and get laughed at. Alright, so write a reverse string. Alright, so write a reverse string function. Reverse string, input string. Okay. Alright, so of course you know how to do this iteratively, right? Iteratively means you go through each one character by character. You start counting from the back. You probably do, output string equals to nothing, and then for I in range, you start at the length of the input string. Oh, sorry, maybe you start from -1 all the way to negative length of input string, something like that. Maybe length of input string +1, maybe. Alright, and then you say output string equals to input string, alright, plus equals to input string I, alright, and that should work, maybe. Reverse string, hello, run, save, potato, none, oops, I never returned it, clever me. Alright, so return output str. Ah! What? Wait, what? What? Alright, so like I said, this is gonna be really embarrassing, but let's just try anyway. So, oh right, to step backwards, you need to tell it to step backwards. Okay, so there you go. Alright, finally, excellent. Alright, I've demonstrated how to get the solution we're not looking for. So, let's delete all this. Okay, so what we want is to reverse the string. To reverse the string, alright, what we want, let's say the input string is hello. Alright, we'll take the last character, alright, which is O, and then add it to reverse string of hell. Alright, okay, so that's the concept. Okay, so we'll say output string equals to input string last character plus reverse string of the input string from 0 to the let's say the second last character. Okay, does it make sense? No, wait, no. 0 to second last character is this is -1, right? Because your indices go all the way there. Okay, so this is almost correct. Alright, if you run this, it will crash. Okay, because at some point you're going to end up with an input string of length 0, in which case you cannot take the -1 of it, right? So in this case, let's say if length of input string equals to 0, return an empty string, right? Otherwise, output string is this, right? Return this output string, okay? And that should give you, alright, there you go. Alright, I didn't cheat, alright? So there you go, that's it, alright? So this is the concept. You take O and you reverse string the hell, alright? And then in this guy's alternate reality, right, in this guy's reality, you take L plus reverse stir of L, And let me just go down the rabbit hole a bit. Alright, this one will be L again plus reverse stir of he. Alright, and then we go down a couple more levels until we get something like H plus reverse stir of nothing. Okay, and that's when this one kicks in. Alright, it returns nothing, and then everything folds back up. Right, so this gets returned to the one before that. Now, you know what? I'm just gonna type in this stuff because it's all I'm doing is saving one level of typing anyway. Plus reverse stir of H. Alright, and then this one becomes like that. Okay, so each one of these returns to the one that calls it. Alright, and you end up with OLLEH. Okay, some people might look at it, might do it this way. Right, you might say, why not just, you know, at this point I can actually go backwards already. I can say length of input string is equals to 1. Then I just return input string. Yeah, it's valid, alright, it's valid. But some people would argue that you have not really found the base case. That's not really the base case. You're skipping ahead, alright, you're cheating. This is not the best recursive solution. The best recursive solution is to go all the way down to nothingness, alright, and then you return. Okay, so this is potato.py. I'm not going to overwrite these because I'm going to use these later. Alright, next. Let's do power. Okay, let's do power. Alright, so power, def power x comma n, alright, says that x to the power of n is actually equals to x times x to the power of n minus 1. Alright, this is, well, I mean, I don't think you guys learn indices until Sec 3 maths, or at least O-level students learn. But that, you know that x cubed equals to x times x squared, huh? This one is stuff that you know, right? So we'll use this, right? Because x times x, let's say x cubed x times x squared, alright? X squared equals to x times x, alright? Then x equals to x times x to the power of 0, alright? So there's a little bit of progression down here. Power of x comma 3 is equals to x times power of x comma 2, which is equals to x times power of x comma 1, which is equals to x times power of x comma 0, and this is the base case. Alright, so again, some of you might argue this is the base case. Nah, let's let it go down to 0. Alright, so let's start by saying output equals to x times power x comma n minus 1. Alright, and don't forget to return the output. Alright, so let's say print power 5 to, well, we all know that 4 to the power of 4 is 32 or something, I don't know. Potato 2. Right, so of course it crashes, right, because it doesn't have a base case. Oh my goodness, help, 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 Control C, Control C. Oh my goodness, why have I done? Help! Alright, Q. Okay, so anyway, we didn't reach a base case. Alright, base case is if n is equals to 0. Alright, if n equals to 0, I return 1, right? Because x power 0 is 1, right? So now I run it and it shouldn't crash. Okay, so there you go. 4 to the power of 4 is apparently 256, which kind of makes sense, I guess. 4 times 4 times 4 times 4. Alright, 16 squared is 256. Okay, so that's it. Alright, this is, the second one is more power, right? That follows this recursion. So this is actually the same, right? It's also finding x to the power n, alright? But it's being a bit more efficient about it. So imagine this, 4 to the power 8, alright? It will call this thing, it will call power, alright? It will call power 7, power 6, power 5, power 4, power 3, power 2, power 1, power 0, alright? It will give you the answer, alright? But it would have created 8 alternate realities to do it, alright? 8 stack frames, okay? So what this does, alright? It does this in a far more efficient way, alright? Let's see. Okay, so def more power x comma n. Alright, so in this case, we just follow this, alright? If n is equal, if n mod 2 equals to 0, alright, that means that n is even, alright, then we will say output equals to power x comma n over 2 times power x comma n over 2, okay? Else, alright, in this case n is odd. If you hear music in the background, it's because I didn't close the door. Then someone's watching TV, sorry. Alright, so anyway, output equals to power, wait, no, it's x times power x comma n over 2 times power x comma n over 2. Okay? And once we're done with that, we just return output. Okay? And over here, we will say if n equals, same base case, if n equals to 0, return 1. Alright? And of course this works, but I've made a couple of mistakes. But never mind, let's just check that it works. 4, 8, 4, 4. Okay, 2, 5, 6 as well. Alright, the mistake that I made is, one mistake that I made is I called the other power. Oops. So which actually recursed itself. Alright, so I should ask this guy to recurse itself, because this one is called more power. More power, guys, more power. Okay, so run. Wah, it crashes. Oops. And I have to kill it again. Oops. Okay, so what happened? What went wrong? Alright. Okay, so I guess because n is odd, alright, n/2 is actually going to give you a float. Alright, so let's do slash slash, which gives you the integer. Alright, and if you can't see it, but it actually does it properly. Okay, so yeah, like I told you, there will be hazards of me doing this. Alright, so this is not very efficient. Alright, though this is slightly more efficient, okay, because each time, so imagine if it's 4 power 8, more power 4, 8, alright, so instead of doing it 8 times, first time round, 8 is even, so you call more power x, 4 and x, 4, alright, then x, 4 will call 2, 2, and this will call 2, 2, and then will call 1, 1, and 1, 1, and finally, alright, you get 1 divided by 2, which is 0, alright, and then it will take that. That's my guess is that is I think 1, 2, 3, 4, 5. That's still about 8 calls, right? So let's make it more efficient, right? Let's call power equals to more power x comma n over 2. Alright, so we ask it to do the recursion once, okay, and then we just use it. Alright, so some of you might find this confusing the first time. You're like, huh, how come I can do that? Alright. In fact, n/2 and n/2 is the same in this case. Okay, so yeah, you can do that. You can store it first and then use it later. Okay, just trust that, you know, first time round, alright, you have n 4, 8. Okay, so first time round you have you call more power 4, 4, which calls more power 4, 2, which calls more power 4, 1. Alright, which calls more power 4, 0. Alright, so by the time it reaches this, alright, you are still stuck at this line for the function above it, right, for the reality above it, alright, but this guy, when it reaches here, it actually returns. Alright, so this guy gets this information, power, POWR is equals to 1, alright, n mod 2 is here, so it's x times 1 times 1, then it returns this up, right, it returns 4, gets 4. Alright, so in this case, this guy gets 4 for this, alright. So in this case, mod 2 is even, so you get 4 times 4, alright, so we take away this reality. This guy gets 16, alright, 16 comes back to this reality, and finally we proceed 16 times 16, you get 48, okay? So you can see that this only takes about 4 or 5 calls, this one takes 8 calls for the power. Alright, okay, great. That's it. Let's go on to the last one. How much time have I taken? Okay, I can take and finish. Right? If I cannot finish, then I'll just stop. I'll just stop suddenly, and you will wonder what happened. And I will never tell you because I don't need to teach you guys again. Ha ha ha. Right. So anyway, sum list, input list. Okay. Third one says recursive function that sums the list being entered. Okay, should be simple enough, right? Because sum list of 1, 2, 3 is equals to 1 plus sum list of 2, 3. Okay, so let's look at it this way. Alright, so let's say output equals to input list 0 plus sum list of input list 1 to the n. Okay, that's it. Alright, and this time I'm even going to skip all the logic. I'm just going to say, what's the base case? The base case is when the length of the input list is 0. In which case the sum is 0 lah. Huh? Alright, so and finally we return output. Okay, so let's test it out. Potato 3. Okay, So in this case, let's use the example here, copy here. Alright, so you do need to print it out, so I'm just going to print. Alright, 37, fantastic. Okay, great. Second one, flatten list. Okay, flatten list, input list. Okay, so this one, actually, I briefly went through under the lists chapter, but that's before we knew recursion. Okay, so flatten list will take a nested list that contains many other lists and flatten it. Alright, so the idea is that flatten list of 1, 2, 3 is equals to 1 plus flatten list of 1, 2, and 3. Okay, that's the base concept. So let's go. Alright, so output list is equals to okay, first of all, wait, sorry. We need to check whether the current. Let's check. First of all, okay, yeah, yes, we can do the base case first this time, huh? If length of input list is equals to 0, what do we return? We are expecting a list, so we return an empty list. Alright, we return nothing. Okay, let's see what's next. So next we need to say output list is equals to input list, the first term, alright, plus, no, sorry. We need to check the type of the input list. So if type of input list 0, okay, let's see. First item equals to input list 0. Okay, if type of first, this is not the best way to do it, right? But you know, it's what we know. If it's equals to a type of a list, alright, then we need to do something, but we worry about that first. Alright, let's assume it's not. If it's not a list, then we say output list equals to, alright, first item plus flatten list the rest of the list, like we agreed. Okay, so input list 1 to the last item. Okay. However, what if it is the first guy is what if it's a list? Alright, so let's consider this guy. Yeah. Alright. So flatten list of 1, 2, 3. I seem to be missing a square bracket here. Okay, flatten list of 1, 2 itself and 3 is equals to, alright, 1, 2 plus flatten list of, okay, so essentially flatten list of the next item. Alright, it looks the same but it's not. In this case, you just take this item, you put it inside a bracket. In this case, you don't even take the item and put it inside a bracket, you take the entire item. Alright, but how do you know for sure that this guy is flattened? Alright, if it's a list, what happens if this stupid list has another list inside? Alright, then you end up with this. So the only way to know for sure is we will flatten list that stupid item. Okay, so we're actually going to flatten list that stupid item. So this is what we're going to do. We're going to say output list equals to flatten list of the first item plus flatten list of the remaining items. Okay, alright, so you see there are two flatten lists on two different things. It's slightly different from what you saw just now. Alright, each of these will go into their realities and just trust that, you know, you've set this up right. You set up the base case, so it's not going to crash. Alright, you set this up right, each of these will give you what you expect. Okay, each of these, you know, you have to believe there's magic. Woo! Alright, alright, so anyway, we're done. I'll return output list. If you don't return that, there's no magic. Okay, so let's say print flatten list of 1, 2, 3, 2, 4. It's really hard to write a flattened list. 5, 5. Okay. Alright, great. Okay, so there you go. I flattened that stupid list that I typed up. Okay, so I used to have 1, 2, 3, 2, 4, 5, 5. I have 1, 2, 3, 2, 4, 5, 5. Okay. I'm so glad that worked. Alright, so finally the last one is do sum nested list. Alright, so def sum nested list input list. Okay, so this one says essentially adds all the elements in the nested list together and returns the sum. Alright, so what essentially it's saying is that okay lah, you as a challenge to yourself, you could do this without writing those two functions above. Alright, that means you as you encounter each item, you add to a total sum and then you flatten it and things like that. Alright, but let's not bother. Alright, what we are going to do is we are going to say flatten equals to flatten list input list. Okay, and then sum equals to sum list of flatten. Alright, and return sum. Oh, we can't use sum. Let's use sum. Summation. Ooh. Alright, so let's say this will return 52. So print this. Okay, run 52. We are done. That's it. It's 20 minutes. Bye. Theory, goodbye.